Here we go. Give me a y-axis. Give me an x-axis. Give me a dot at the origin. Remember, Thomas, you're going to be with me on the quiz, right? You might want to, this will be on the quiz this Friday. All right. Give me one side of the angle and label it initial side of the angle. And let's say the angle stops right here. We're going to put an arrow. So it's going to rotate. This would be called the terminal side. So you have to start thinking of angles where the origin is where the angle, the vertex of the angle, and we're rotating around and around. Okay, and we're going to be measuring in radians now. So we have the terminal side where the angle stops and the initial side where the angle begins. That's from 2 days ago. Now, on the quiz, and what you got to know is if I throw a degree at you in radians, you have to convert that and draw that into standard position of an angle. Here's what I mean. Example 1. Draw the angle 11 pi over 6 radians in standard position. Draw the angle 11 pi over 6 radians in standard position. Oh, that's right, you can do it. That's right. Remember, you're going to be quiz this Friday. Again, those of you who are done with my class, you still got to focus on what's current. 3 of you. All right, standard position. Let's draw it. Okay, x-axis, y-axis. Okay, we're dealing with radians. How much is 1 pi radians? Half a circle. So look at this is 1 pi. Every half circle is 1 pi. Look at 1 pi, 2 pi, 3 pi, 4 pi, and so on. The question is, how many pi's is this? 11 over 6. A lot. So it's 11 pi's again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi's, and then divide that by 6. Another way to see it would be just take 11 divided by 6 and convert it to a simple decimal. So 11 divided by 6 would be what? Let's see. Yeah? Cool. That sounds good to me. So look at 11 divided by 6 is 1 point. Let's run the nearest 10. 1.8. But the next one's 8, huh? So it's 1.9.
No, the next one's 3.
Okay, so 1.8 radians. So look at 1.8 pi. So if I want to draw this in standard form, this is 1 pi. Here's 1.5 pi. So 0.8 would be about right here. Look at my logic. How many pi's do we have? 1.8 of them. 1 pi, 1.5 pi. Because I think Gomez did that one for warm-up. Look at that. That'd be 1.5 pi. And so let's see, 1.5, 0.6, 0.7, 0.8, 0.9, and then there's 2 pi. So 0.8 is about right here. Draw the terminal side. Look at, you're going to draw the arrow. Look at the loop that shows you how the angle was formed. Draw that. This loop shows the rotation of the angle. So that angle rotated more than almost a full revolution. So this would be 11 11 pi over 6 radians.
That's how the answers are going to be on the quiz.
Right, so I'll throw you a radian measure and you draw me the angle. It is easy. But sometimes angles will go more than one full revolution, so you have to draw that loop going more than one time around. For instance, try example 2. It's pretty simple. How about 4 pi radians? Draw that one in standard form. Here we go. X-axis, Y-axis. Okay, so 4 pi radians, look what I'm going to do. 1 pi, 2 pi, 3 pi, 4 pi radians. There it is. Okay, the terminal side is actually exactly on the x-axis because it's 4 pi radians. I trust you see my logic here. Half a circle is 1 pi radians, 2 pi radians, 3 pi radians, 4 pi radians. So it's actually 2 revolutions. 4 pi radian angle would be a double revolution angle. So far so good, I trust. This is a new kind of logic of looking at angles. Okay, let's keep going. Example 3. Negative 3 pi radians. So you can have a negative angle, yes. You're going to go down.
So you're
A negative angle would be an angle going down and going actually clockwise. Okay?
So
let's do it. Exactly.
1.5.
1.5 on, exactly. So here's your x-axis, here's your y-axis. So negative angle would be clockwise now. Revolution is going clockwise. So we're going to go clockwise 3 pi's. This is negative, this is positive, so we're going to go clockwise. So 3 pi. I'm going to count them. 1 pi, 2 pi, 3 pi. There it is. It is easy. Once you get the logic of how radians work, the tough part is getting the logic of how a radian works. That's what I was trying to do yesterday. And so you always start, remember standard position is the x-axis here. So it always starts here. The initial starts here, and you either go negative direction or positive direction. And give me the loops and where it ends. Example 4. Oh, you're in the right. All right. Let's go. Let's go. Pi over 2 radians. Pi over 2 radians. Try that one on your own without my help, see if you guys can get that. What would it be? Well, describe the angle to me. How many degrees would it be? Try again. It'd be a 90-degree angle. So watch this. How many pi's is that?
1.57.
Well, remember, how many pi's? Right, so how many pi's is that then?
0.5.
Right, it'd be 0.5. That's 1 pi, but I'm taking pi and cutting it in half. Another way to see it would be 1/2 pi, right? 1/2 pi and pi over 2 mean the same thing. So how many pies am I dealing with? A half a pi. So here we go. X, Y axis. Okay, we're in positive direction, so the angle's going to go counterclockwise. This is 1 pi, so I'm going to go half a pi, right?
Yeah.
What's the matter, Gomez?
It's gonna be pointed up.
Right. So it'd be a 90-degree angle, perpendicular angle. So so go like this. This would be pi over 2 radians. Easy. Come on, guys, you with me?
Yeah.
You got this, huh? Okay, you gotta be held to it. A couple more examples. Example 5. It is. How about 12 sevenths pi? Let's go 12 eighths pi. 12 eighths pi. The first question you always want to ask yourself is self. How many pi's do I have? The 1.5? Let's see. 12 divided by 8, is that 1.5?
Yeah.
As a decimal? Nice, so it's really 1.5 pies.
So it's 270.
Exactly. 1.5 pi. Draw the loop. Done. Last example. Example 6. Five over 3 pi. 5/3 pi. So the question you're gonna ask yourself is how many pies am I dealing with? 1.6 pies.
You round 1.2.
So 1.7, yeah, so around the nearest tenth, it's about 1.7 pies. Let's do it. How many? About 300? Yeah, that sounds right. So it'll be in the fourth quadrant of revolution. So 1 pi, 1.5 pi, and I'm going to go to 0.8, you said, or 7?
7.
Okay, so 6, 7, 8, 9, so about right here. There it is. You just estimate at that point when you get to after 0.5. As long as it's around the ballpark, you're going to be good on the quiz. So this would be 5/3 pi. Radians.
2.
Easy, right?
Yeah.
Okay. You'd be surprised at how confused students get when you start dealing with radians. It's crazy. All right.
Yay.